Today's artificial limbs are a far cry from the wooden leg of yesteryear. They look very realistic, and thanks to advances in prosthetic technology, artificial limbs function more and more like the real thing. They start by measuring the amputee's stump, what doctors call the residual limb. First, they measure the circumference at different points. Then the diameter at different points. They protect and lubricate the residual limb by coating it in petroleum jelly. Then they immerse it in algin, a gelatin-like substance that comes from algae. After about 5 minutes, they remove the residual limb. The algin has already begun to stiffen and maintain the limb's shape. A couple of hours later, it's stiff enough to be used as a negative mold. They pour in plaster of Paris, then insert a metal rod. The rod is what will later allow them to mount the dried plaster to work on it further. The plaster takes about an hour and a half to harden. They cut off the algin. Then, using sandpaper and files, they refine and smooth the surface. This plaster copy of the residual limb will now be used as a positive mold to cast the artificial limb. Often, they use a different technique to make the positive mold. They build a negative mold first using strips of plasterized cloth, much the same way they make a plaster cast when you break your leg. Then a scanner takes a detailed three-dimensional reading and programs it into a computer. A technician then makes any necessary modifications. They put a plaster block on a cutting machine. The computer guides the blade to carve out the positive mold. With either technique, once the positive mold is ready, they can make the artificial limb. The process they use is called lamination. First, they cover the mold in fabric socks. Some made of nylon, others of a material that contains fiberglass. They layer 6 to 10 socks in all, depending on how rigid they want the artificial limb to be. Then they coat the socks with a liquid resin made of either polyester or acrylic. Here they're using acrylic tinted to look like Caucasian skin. It's important to ensure the surface is evenly soaked. It's a meticulous process that takes about an hour. The acrylic solidifies in about an hour. Polyester takes about 12 hours. They then break the plaster mold inside, leaving a durable plastic shell called a socket. That will be the basis of the artificial limb. The socket connects to another plastic shell containing the mechanics. Or, like this artificial leg, the mechanism can be modular and covered in just a skin-colored foam. If the muscle at the site of the amputation still emits a good electrical signal when contracted, the patient can get a myoelectric prosthesis. It has an electrode that captures and amplifies the signal, triggering the artificial hand to open and close. Today's artificial limbs are a far cry from the wooden leg of yesteryear. They look very realistic, and thanks to advances in prosthetic technology, artificial limbs function more and more like the real thing. They start by measuring the amputee's stump. What doctors